what we have is the complex issue of the refining of crude oil. And it involves various products, such as the liquefied petroleum gas, the naphtha, kerosene, diesel, gas oil, and long residues. And in this, process optimization and sound process control must be employed, relating to offset conditions, startup, shutdown, emergency, and again, required adequate process safety management system. And I'll talk on this later on. My presentation this afternoon will focus on four main parts: petroleum chemistry, petroleum refining processes, involving crude distillation unit. This is mainly a modular unit, or it can be a modular unit, cracking unit, reforming unit. Number three will relate to emissions energy management from the refinery processing units, and finally, the integration of the refinery with the petrochemical plants. Latterly, in the States, what has happened is that the Biden administration has provided some incentives to some refiners to switch to sustainable alternative aviation fuel involving biomass, vegetable oils, and so on. But this presentation will focus mainly on crude oil and not the sustainable type of refining. Now, this is just a snapshot of a table relating to the various countries and continents providing the amount of crude oil per day. And in particular is the Jamnagar refinery in India, which I like us to just note. There's the new Dangote refinery, which is 650,000 barrels. And of course, the Sasref refinery in Saudi Arabia, which is 203,000 barrels per day. It has a 2-train into the crude distillation unit. And again, what we've got here will be the average refining capacity in the States and in Europe. I'll just like us to be mindful of these values, which I'll be describing later on in my presentation, ladies and gentlemen. All the others from other parts of the world are as shown here in the table. And this comes from these crude types from Saudi Arabia, involving the range of crudes from the heavy crudes to the light crudes within these various range of the American Petroleum Institute. And what we've got are the types of crudes from being sour to light. The sour crudes contain a lot of sulfur content. And of course, these are highly premium types of crudes, which are highly paraffinic in nature. And again, what we've got here on the left-hand side of this slide is just the phase change between the gas to solid, involving the different crude oil qualities. Now, the classification of crudes involving mainly two types, the aliphatics and the aromatics. And in the aliphatics, what we've got are the saturates, involving the alkanes, which are the paraffins, and the naphthenes, which are the cycloparaffins. And of course, we've got the aromatics, which are the benzene, the toluene, the xylene. These are the general formulas of all these. Please bear in mind, ladies and gentlemen, that we do not have these in the crude, which are the olefin, the unsaturated. These are actually produced during the refining in the FCC, which is the fluidized bed catalytic cracking unit, which I'll talk on later on. I'll show you a video on that. The crude also contains a lot of metals, sulfur contents, nitrogenous compound, and salts. These must be removed during the refining process. The reason is that they could have severe adverse effects on the various process equipment, such as the vessels, the heat exchangers and the pumps and so on, relating to corrosion, plugging of the heat exchangers, of the tubes of the heat exchangers and so on. So we must be confident on these things. Now, the classification of hydrocarbon is as shown here, from methane to 𝐾𝐞𝐦𝐲𝐬𝐭𝐢𝐟𝐻𝐿𝐴. These are highly long-chain hydrocarbons as one goes down, and the various products from these are the natural gas down to the petrolactum. Now, if we look into these octane carbon atom compound, rather, what we've got is the normal octane here. These are all normal paraffins. Now, if they're isomerized, this particular one relating to having a branch chain of it, we could convert it into another structure, ladies and gentlemen, which is known as 2,2,4-trimethylpentane. And it's an iso compound. It has an octane rating of 100. As compared to this particular structure here, this compound, which is normal heptane, it has an octane rating of 0. And is a measure of the anti-knock resistance of a gasoline. And of course, what we have, again, in the categories classification of crude oil, basically, apart from the various compounds which we've highlighted over earlier on, such as the salts, they are mainly paraffinic, naphthenic, and aromatics. As you could see, the paraffinic has a long chain. It's got a carbon atom attached to the hydrogen atom. This one has a carbon atom attached to 2 hydrogen atoms. It's cyclic. Of course, this is highly reactive. It's got a double bond with it, with the carbon atom attached to 1 hydrogen atom. And here, if we look at the triangle, the crude will be in the middle of this triangle. And the reason is that it consists of various percentages of the paraffinic, the naphthenic, and the aromatics. So all the various crude types are a proportion of these various compounds, ladies and gentlemen. Again, what we can classify, how do we classify the crude? We've got these American Petroleum Institute formula relating to the specific gravity, and we can have the reference as the specific gravity of water. If we flip to this chart, from this simple equation, we can get this profile, ladies and gentlemen. And we can classify our range of crudes, which we know from all these, knowing the specific gravity, we can then classify to these different categories of the crude types, as shown here. And the light crudes will be above the 30 mark of the American Petroleum Institute standard. Another type of classification relates to the assay data. The assay data allows us to have various series of experiments. And these are the various tests that could be carried out, from the API, which you have just highlighted, to the Watson characterization factor, as well as these other ones, ladies and gentlemen. An example of the number 2, which is the Watson characterization factor, is obtaining the mean average boiling point at these various percentages which have been distilled. We find the average from this volume that has been distilled. It's in the old unit, which is the Fahrenheit. We add a constant value to it. We know the specific gravity, and using that simple formula, we'll be able to classify the types of crudes that we've gotten, such as within these various ranges, either paraffinic, naphthenic, and aromatic. Now, another classification relates to what is called the true boiling point. It's a basic tool which allows the refiner to decide how suitable the crude is before it goes on into production. It uses the American Society of Testing and Materials, involving 15 theoretical plate columns, as you could see in that diagram. Now, there are different cuts relating to the various fractions that are obtained between the butane, the gasoline, down to the residue. And it involves the cuts with the initial boiling point of these various fractions at which they start to boil up to the final end point when 100% of these fractions has actually been vaporized. So we can determine the various cut points either in Celsius or in Fahrenheit. And again, we can have our plots, and these are various plots, yeah, for the heavy and light crudes. And you could see the various endpoints there from butane to the residue. And that completes the chemistry aspect of the crude type, of the various crudes. Now we're going to the production. But before we do that, ladies and gentlemen, I need to explain this particular flow diagram. I just spend a little time in explaining it, because what we've got is, this is the heart of chemical and process engineering, ladies and gentlemen. We have raw materials, which we're trying to convert into products. And in doing this, we need what is called reactors. And a typical reactor is this, which is a batch reactor. The others are continuous state tank. The ones used in the refinery are the fixed bed and the FCC, the fluidized bed. Others are still used, but these are the main predominant ones in the refinery. And again, we must understand the kinetics, the rate of reaction relating to the kinetics, the concentrations, and the Arrhenius equation, activation energy. Now, when we're dealing with catalysts, this is very important, ladies and gentlemen. Of course, again, we must understand the thermodynamics involved, whether it's releasing heat or it's consuming heat, as the case may be. But we know that the rate of reaction doubles for each degree rise in temperature. And if we're dealing with a catalyst, that is very serious for us, relating to the heat of generation, because it is being into the system in the reactor, it's taken out, relating to the heat of removal. And that happens in the hydrocracking unit and the hydrotreating unit. And these I will explain further in my presentation. If that rate of generation is greater than the rate of heat removal, we have a problem. And that problem is what is called a thermal runaway. And if that is not being controlled, what happens, and it has happened in the past in some of these refineries, is the result of explosions with the loss of lives, ladies and gentlemen. So we need to be able to control the thermal runaway in these chemical process, which are the reactors. And an example of this is if we flip through to this part here, there's just a triangular representing a fire triangle involving a hot catalyst, hydrogen, and hydrocarbon. If we're able to at least suppress one of these components, we may be able to adverse the runaway process taking place. In any case, we've got the products and our reactants, which can be, they will need now to be purified. And in doing that, we need these unit operation process. Examples are distillation, extraction, as the case may be. Mainly, fractionation will allow us to separate a lot of our products for purification. Some of the unreacted reactants will be recycled back to the reactor. After the purification, we get in our products. In some cases, we've got the formulation. And this is the main structure of what will be happening in the refinery. Now, here's a photo of a typical refinery. And what we've got here in the typical photo is an incredible series of pressure vessels, and as shown here, distillation columns, heat exchangers, pumps, and so on, and tanks, storage tanks. We've got a fire heater and a network, incredible network of pipelines. conveying flammable, corrosive, combustible fluids, maybe of a single phase, a two phase, or a combination of all. And they will go through various instrumentations, such as got a pressure gauge there, measuring instruments, valves, such as gate valve, globe valves, as the case may be, and valves, and of course, relief valves to using the overpressure, overcoming the overpressure of various vessels. And of course, we've got the metering. And if we look closely here, we've got porta cabins in this particular refinery. An incident happened in 2005, ladies and gentlemen, whereby with the BP refinery, there was an explosion with 15 people in one of these porta cabins that lost their lives. And you can see, visit the website to see more on the animation of this. So what happens is the next stage is these ultra sulfur diesel, whereby we are removing the sulfur content. This is just a photo of a plant whereby desulfurization process is taking place in removing the sulfur content to a maximum of 15 parts per million, which is relatively the limit set by the environmental board. An example would be the EPA, the Environmental Protecting Agency in the States, or the Health and Safety Executive in the UK, or many other boards whereby a limit is being set for the reduction of sulfur in the diesel. Now, here is a simple, it's a laboratory simulation lab whereby process operators will, or panel operators will need to be able to maintain, to operate in terms of the understanding the various process instrumentation relating to startup, shutdown of various units. Again, relating to the trips that could occur in the pumps or motors or valves. So basic to mastery knowledge involving the KPI must be acquired. Otherwise, it presents a difficult problem for people going to the plant. An example maybe of this, which is the a fired heater. You could see all the various instrumentation related to it, connected to it, and the understanding, the operation, the trips, the startup, shutdown of these must be acquired. Likewise, again, with a distillation column, whereby the operation of the distillation column relating to the profile involving the pressure, the temperature, the flow rates, the offset conditions that will occur relating to flooding the column, foaming of the column, whipping, and so on. These are items that the operators must be aware and be expert in troubleshooting and correcting. Likewise, in the vacuum distillation unit, as shown here, the same thing applies. Before it then goes on, or she then goes on into the control room of these various units relating to the crude, hydrocracking, and the reforming unit. And here are examples of the photos that are in the refinery. An example is this, the distillation column, the fixed bed reactor, and others are centrifugal pump, shell and tube heat exchangers. This one happens to involving a turnaround issues. And of course, we need to acquire the necessary work permit for the work to be conducted during the turnaround. It's an interval of about 5 to 6 years in a refinery where various maintenance work is being carried out. An example here is removing the shell and tube heat exchangers for cleaning because it's being fouled with coke. And of course, the personnel involved with a supervisor seen to everything is working in good order, we will have the various process and safety equipment like helmets, the gloves, and shoes, and so on and so forth. Now, the crude units, the descriptions in the refining is all listed here. These are the various process units, which are all numbered, ladies and gentlemen, and the corresponding description for each of these is also stated, from the crude distillation unit up to FCC unit, the amine, and the utilities as well in the reforming unit, whereby we're able to obtain the hydrogen, which I'll talk on later on in this presentation. Now, this is a typical flow diagram of a refinery. Can you see the arrows? And if we look at the arrows, they from left to right, the products will act as raw materials for other treatment in these units. So as the arrow goes, we're having the desalted crude into the atmospheric distillation column. This sector here, ladies and gentlemen, is known as the crude distillation unit. The sector here is the cracking unit, and the reforming unit is that it's actually expansive relating to the various refinery facilities. At SASRE, for example, the reforming units also involves extraction column, whereby they then produce the aromatics, the benzene, the xylene, the toluene, for the other company, for the petrochemicals, such as the SABIC, whereby they make the xylene. From the xylene, they're able to make the styrene, or ethylbenzene rather, from benzene to ethylbenzene to styrene. At the top here is the gas processing units. So they are all well defined, ladies and gentlemen. These products still contain a lot of impurities that will need to be purified, and this is where they're treated. You see the gases? These gases will be the C1 to C4 or C4. Hydrogen is actually used. An example here, ladies and gentlemen, is number 6, which is the 𝐃𝐞𝐦𝐲𝐬𝐭𝐢𝐟𝐲𝐬𝐧𝐠 My name happens to be there, which is maybe a compliment, but I don't own this unit anymore. What happens is we've got the raw material which is being fed in, which is the product from the vacuum unit. And a combustion, it goes into different drums in the 𝐃𝐞𝐦𝐲𝐬𝐭𝐢𝐟𝐲𝐬𝐧𝐠 unit where combustion takes place with time, and we're getting various products, such as the gases, the C1 to C4, coke and naphtha, gas oil, and the petroleum coke. These petroleum coke, ladies and gentlemen, can further be gasified in producing CO, CO2, hydrogen, and some sulfur impurities, and some, again, particulate matters. And in other syntheses, there's a Fischer-Tropsch synthesis whereby the CO2, which is now being added with hydrogen involving iron and cobalt as a combination of catalyst, can again produce an aliphatic, an hydrocarbon. This is actually used in the sustainability that I talked earlier on, involving vegetable oils or biomass, relating to this removal of or the carbon capture. Of course, here we've got the hydrogen synthesis, whereby hydrogen is being manufactured for the treating. As you saw on table 1, there is the Nelson Complexity Index, and I mentioned that at the first table, and it's well defined in the glossary that you can download later on after this presentation. And what we have here from this simple formula is the Jamnagar refinery has the highest, and the reason is that it has all the various units attached to the refinery. So it's got the petrochemical units for producing propylene and so on and so forth. The Dangote refinery, which is just being commissioned and is in operation, is 10.5 again, because it has an add-on of petrochemical units attached to it, such as the production of polypropylene, maybe ammonia, urea, and so on. The SASREF refinery is 7.7 in Saudi Arabia. And of course, the averages of the USA and in Europe are these respectively, ladies and gentlemen. So the methane is reforming is the production of hydrogen, which is then used for the hydrotreating and hydrocracking unit. It uses the natural gas, steam at high pressure steam, high temperature, uses catalyst, and we're getting products. Again, the thermodynamics involved is a combination of endothermic and exothermic. And these are the products. The product, which is carbon dioxide and hydrogen. The hydrogen here, by the way, is known as the gray hydrogen. And if carbon dioxide is being captured in this synthesis, it then turns to be blue hydrogen. Of course, the green hydrogen is when you use the electrolysis or use the biomass. In any case, once we've gotten our products, they will need to be separated. And the only way we can do that is to use what is called a pressure swing adsorption. The carbon dioxide can be compressed and it could be stored or be used in various petrochemical process. Basically in the crude distillation unit, which is again a modular unit in some of the refineries, which are small scale refineries, is we've got the desalter, removing the salts, we've got the sour water, which is the H2S, and of course the desalted crude could be pre-flashed in some cases, and of course the gases will be sent to the column, or alternatively it goes through the heater, fired heater, again increasing the temperature of the crude at a very high temperature of the 370 degrees Celsius. Steam is being applied at low pressure steam, and we're getting various separations in this column. The columns could have holes, sieve plates, or bubble caps, as the case may be, and we're having the products relating to the relative boiling points. The lower boiling points will rise up at columns, and again, the volatility and the vapor pressures, the ones with the higher boiling points will come down the column as liquids. We're able to condense, we're getting the gases, we're getting the naphtha as well, the sour water containing H2S. Some of the naphtha is being recycled, refluxed, pumped back to the top of the column to maintain what is called the vapor liquid equilibrium. And we're getting various products, and these are pumped around again for the reflux. The bottom is the long residue. We don't wish to crack this so that it could have adverse effect on the metals. And this just shows the operation taking place between the bubbles and the liquids in the column. This is a plate of the bubble cap with the vapor rising through the slots, mixing with the liquids, vapor liquid equilibrium, and the liquid flows down the downcomer. And the long residue from the crude distillation unit, and by the way, so far it's a physical separation taking place, making use of two parameters, temperatures and pressure. There is no chemical reaction yet. So what we've got with the long residue is going through the furnace at a high temperature. Here, instead of using plates, we're using packings. These are the packings to reduce the pressure and having a low pressure. Of course, a vacuum is being applied. We're getting our products as well as the distillates and the long residue. And now in the hydrocracking process, what we have are the feedstock. We've gotten the waxy distillate from the vacuum unit. It goes through the various packed beds to promote reaction, and catalyst being involved. And this is the fixed bed reactor. And of course, what we are having here is the impurities are being converted into these various compounds, such as hydrogen sulfide, ammonia, water, as the case may be. It uses nickel as a catalyst. The product will fed through to the second reactor. And of course, remember what I said earlier on about the runaway reaction. This will need to be controlled. Otherwise, and of course, the parameters involved will be the temperature, pressure, as the case may be, for the thermal runaway. We've gotten our products, and these products will now have to be separated. How they've been separated again in the distillation column to get these various products for usage. I'm going to play a video of the
hydrocarbons are first fed into a reactor where they mix with the catalyst. The heavy liquid hydrocarbons are converted into lighter hydrocarbon vapors as they travel up the reactor. At the top of the reactor, the lighter hydrocarbon vapors are separated from the catalyst. The hydrocarbon vapors then flow to the main distillation unit. The catalyst falls down the side of the reactor where it moves through a slide valve to a piece of equipment called the regenerator. During the reaction, a layer of carbon called coke forms on the catalyst that must be removed. Inside the regenerator, air is added, and the coke on the catalyst is burned off. The catalyst is then fed back to the reactor through a slide valve, and the cycle is repeated. When the coke is burned off the catalyst, this creates products of combustion called flue gas. The flue gas flows out the regenerator and enters a system comprised of multiple pieces of equipment, which remove any remaining catalyst particles present. The regenerator and flue gas system comprise the air side of the FCC unit. The last piece of equipment in the flue gas system is called the electrostatic precipitator, or ESP. The ESP removes small catalyst particles using static electricity. While the ESP is energized, it creates sparks, which are sources of ignition.
Right. And what happens here, ladies and gentlemen, is that in this unit, there were some explosions in the ExxonMobil refinery in 2015 and the 𝐃𝐞𝐦𝐲𝐬𝐭𝐢𝐟𝐲𝐬𝐭𝐢𝐻 refinery in 2018 in Wisconsin. You could see the animations of these from this website, ladies and gentlemen. And process safety management is a very important issue. Another disastrous explosion with the loss of 15 lives happened with the BP Texas refinery, and over 180 got injured. You could also see the video of the animation of these from that website, ladies and gentlemen. So process safety management system must identify, evaluate, and also control process safety hazards. And again, we have in our products, and from the various refining, these are the uses of these products, as mentioned by Dr. Sunday in the beginning of his presentation. These are household uses of these various products from crude oil, ladies and gentlemen. The one that the Americans are now switching to is the SAF, which is the sustainable aviation fuel, using biomass or vegetable oil. And that is just an animation of what happens in getting, again, the hydrotreating, the hydrocracking, and getting these various products. So that completes the third part of, the second part of my presentation. The remaining parts, ladies and gentlemen, relate to global warming issues, energy management, and there are various gases obtained, such as C2H4, CO2, CO, NOx, and so on, and from fugitive emissions from the various piping networks. This will need to be controlled, ladies and gentlemen. And again, the energy management will relating to energy audits, relating again to the various areas of waste savings, potential energy savings, energy optimization, involving various process controls, heat recovery system, involving pinch technology, as the case may be, and cogeneration, which is a combined heat and gas, and fuel gases, which are obtained from a different from this unit, as you can see here, the off gases. Again, from the FCC unit or the reformer unit can be used for heating and powering equipment, ladies and gentlemen. And again, for flaring, the gases, which are the C1, C4 to C4, are sent through to the flare header. And at elevated temperatures, they can be converted into CO2 and water vapor. And flaring actually helps to prevent release of unborn gases to the atmosphere. And finally is the petrochemical issues, whereby we've gotten our products. The products can then send through to the petrochemical plants, as in the Jamnagar refinery in India, or the Dangote refinery in Nigeria, to make propylene, as the case may be, or in some cases to make urea. These are some of the products from the petrochemicals, obtaining these from the refining, the benzene from the reforming units to make the styrene. The intermediate there is the alkyl benzene. So in conclusion, what we can say, ladies and gentlemen, is that at least 46 is still needed for gasoline, whereby 54 is for the petrochemicals. And the refining facilities can be integrated, as we have just highlighted, to make these various products, such as the methanol, ammonia, urea, plastics, and so on. Of course, the green gas emissions is now the in thing in terms of CO2, which can be captured. And there are various technologies in capturing that right now being implemented. And along with various research work is still continuing. The captured carbon dioxide can then be used to make all these, ladies and gentlemen. So thank you so much. And the glossary can be downloaded at the end of our presentations. And I look forward to answering your questions later on. Many thanks.
Thank you so much, Dr. Kayode, for your wonderful and insightful presentation.